Today we're on pages 182 and 183 of our textbook. You want to have your graphing calculator and a highlighter. Lesson 5, the zero product law is this. If the product of multiple factors is equal to 0, then at least one of the factors must be equal to 0. For example, if I have 8 times something equals 0, then what is that something? Well, it would have to be 0. The law can be used in exercise number 1. In this exercise, quadratic equations are already in factored form. Solve each of the following equations for all values of x. So we have something times something else equals 0. So that means either the x plus 7 is equal to 0 or x minus 3 equals 0. So we set each factor equal to 0. And solve individually, subtracting 7 from both sides. So x equals negative 7 and x equals positive 3. I'm going to write this in solution set notation. So if 2x minus 5 times x minus 4 equals 0, then either 2x minus 5 is equal to 0 or x minus 4 is equal to 0. Solving, adding 5 to both sides, I'm not going to show that step, and then dividing by 2. Adding 4 to both sides. So we have two solutions here for x, 5 halves and 4. Number C rather. We've got 4 times 3x plus 2 times 4x minus 3 equal to 0. So that means either the factor 4 equals 0, which is not a true statement, so I'll just cross that off, or the factor 3x plus 2 is equal to 0, or the factor 4x minus 3 is equal to 0. So now we solve each of these individually for x. Again, I'm not going to show the step. I'm going to subtract 2 from both sides. 3x equals negative 2, and then divide by 3. X equals negative 2/3. Here, add 3 to both sides, and then divide by 4. X equals 3/4. So our solution here is negative 2/3 and 3/4. In exercise 1C, why does the factor of 4 have no effect on the solution set of the equation? It has no effect because the factor of 4 is a constant. It's a constant or numerical factor. The zero product law can be used to solve any quadratic equation that is factorable. It can be used to solve any quadratic equation that is factorable. To use this technique, you must first set the equation equal to 0. Then factor the non-zero side, and then set each factor equal to 0 and solve for x with each factor. So you first set the equation equal to 0. In other words, we put it in what's called standard form, where we have all our terms on one side and 0 on the other side. Then you factor the non-zero side, and then you set each factor equal to 0 and solve for x. Solve each of the following quadratic equations using the zero product law. Okay, so for A, so our x squared term is on the left-hand side and it's positive where it is, so I want to keep that there. So I'm going to bring these two terms over to the left-hand side by going to add 2x. And put that in line with its like term on the left-hand side. Excuse me. And then I'm going going to subtract 10. Do this in one step. Okay, so we have x squared plus 5x minus 24 equals 0. So this is what we call standard form. Now, it's a trinomial on the left-hand side. The leading coefficient is 1. So we go to the constant, negative 24. What are the factors of negative 24 that sum to 5? 8 and negative 3. So this factors into x plus 8 times x minus 3 equals 0. Now we set each factor equal to 0. Subtracting 8 from both sides, x equals negative 8. Adding 3, x equals positive 3. So our solutions are negative 8 and positive 3. For B, same thing here in that, I have a 3x squared on the left-hand side and a 1x squared on the right. I always like to, and you should do the same, always work with a positive leading coefficient for your x squared term. So I'm going to bring all 3 of these terms on the right over to the left by subtracting x squared, subtract 3x, and add 2. (2x squared plus 9x minus 5 equals 0. Here we have a trinomial. The leading coefficient is greater than 1, so this is where we do the rainbow. And we multiply 2 times negative 5 and get negative 10. And now the factors of negative 10 that sum to 9 are 10 and negative 1. Because we did the rainbow, now we split up 9x into 2 terms, 10x and negative 1x. Switch back. So I have 2x squared plus 10x minus 1x minus 5. I'm just going to hold off on the equal 0 because this is kind of like middle work here. So now split, bring down the operator, take out the GCF here, which is 2x. Plus 5 in parentheses, and what's common here is 1, but we're really taking out a negative 1, so that is x plus 5 in parentheses as well. So x plus 5 is one factor, and what's outside, the 2x minus 1, is our other factor. Let's go back to our equation, equals 0. Now we set each factor equal to 0. Subtracting 5 from both sides, x equals negative 5, adding 1, and then dividing by 2. So we have negative 5 and 1/2 as solutions. Exercise 4 asks us to consider the system of equations shown below consisting of a parabola and a line. This is our parabola, right? It's quadratic. And this is our line. This is linear. Find the intersection points of these curves algebraically. Well, the intersection points occur when the two equations are equal to each other. So let's just look at that first. So the intersection points occur when or where, let's try this again. The two equations are equal to each other. So algebraically, we set them equal to each other. 3x squared minus 8x plus 5 equals 4x plus 5. We want to put this in standard form. So we're going to subtract 4x and subtract 5 from both sides. X squared minus 12x, that's 0, equals 0. Now we factor this. Well, there's only two terms. There is a GCF. That GCF is 3x. Factor out 3x and we have x minus 4. Now we set each factor equal to 0. Divide by 3, x equals 0. Add 4 to both sides, x equals 4. So we have x equal to 0 and x is equal to 4. So that's solved algebraically. It asks for intersection points. Sorry, we're not done. When x equals 4, what does y equal? So I'm going back to my linear equation, which is easier to work with. And when x equals 0, y is equal to y equals 4. We substitute 0 in for x. So y equals 5. So this is the ordered pair. Our solution here would be the ordered pair, 0, 5, right? X, y value. And when x equals 4, what does y equal? 4 times 4 plus 5. 16 plus 5 is 21. So this is 4, 21. So these are our intersection points. 0, 5, and 4, 21. These are our intersection points. Using a calculator, sketch a graph of this system on the axis to the right. Be sure to label the curves with the equations and the intersection points and the window. Okay, so we go to y equals, we put in our two equations. Right. Now we press graph. And we see only the one intersection point, the 0, 4. Right? So we need to adjust the window on our calculator. So we press window. And it's our y value that we need to see more of. So let's change the y max to, we know it intersects at a y value of 21, so I usually go a little higher than that, go with 25. And let's see what that looks like. Okay, so this is a sketch. First thing I'm going to do is to scale our axes. So 25 is up here. Don't stop switching on me. So I'm going to do 5, 10, 15, 20, 25. And let's see, 1, 2, 3, 4. And on the calculator, the parabola is in blue. So we'll switch to blue. The turning point on my parabola, let me just take a look at my table. Right. Input of -1 has an output of 16. Alright, so I'm going to try to plot a few points here. 0, 5. Sorry about that. I don't know why that happened. Jump up to 421, about right here. I'm estimating here, and negative 116 out here. Okay, so I'm going to use this to try to sketch out my parabola. Label this with its equation, y equals 3x squared minus 8x plus 5. And now I'll switch to red for the line. What was the y-intercept was 5, and the slope of 4. So if I go up 4 and over 1, that looks pretty good. And if you have a straight edge, take a straight edge. Try to line that up. It's quite a wavy line. It's not very straight, but that's okay. And this is y equals 4x plus 5. Alright. And our intersection points are 421 and 0, 5. Verify your answers to part A by using the intersect command on the calculator. So second trace, number 5. First curve, you just press enter. Second curve, enter. Guess, press enter. 0, 5. And then do that again. Second trace, number 5. First curve, enter. Second curve, enter. Guess. I have to move it closer to the other point of intersection, otherwise it's going to give me the same point it just determined. 421, so that's correct. The zero product law is extremely important in finding the zeros or x-intercepts of a parabola. The parabola shown at the right has an equation, y equals x squared minus 2x minus 3. Write the coordinates of the two x-intercepts. Our x-intercepts are here, right, and here. We want the coordinates, negative 1, 0. Keep switching. Negative 1, 0, and that's 3, 0. Find the x-intercepts of this parabola algebraically. You notice that the output is 0, so take our equation up here and replace y with 0. So we factor. The factors of negative 3 that sum to negative 2 are negative 3 and 1. So we have 0 equals x minus 3 times x plus 1. Set each factor equal to 0. Adding 3. Subtracting 1, and there we have 3 and negative 1. Algebraically find the set of x-intercepts or zeros for each of the parabolas given below. Okay, so when you're zeros and x-intercepts are the same, this is when you replace y with 0 and solve the equation for x. Zero equals 4x squared minus 1. We're going to factor this. This is a difference of perfect squares. It factors into 2x plus 1 times 2x minus 1. We set each factor equal to 0. And then solving, subtracting 1 from both sides here. And you don't have to show this step, and usually I would not. 2x equals negative 1, and then dividing by 2. X equals negative 1/2. Add 1 to both sides, divide by 2. So here's our solution, negative 1/2 and positive 1/2. B, again replace y with 0. And factor. No GCF, the leading coefficient is greater than 1, so we do our rainbow. 3 times negative 10 is negative 13. Now let's try negative 30. The factors of negative 30 that sum to positive 13 are a positive 15 and a negative 2. So that would be negative 2 and positive 15. So we're rewriting our trinomial as 4 terms, taking the middle term and expressing it as negative 2x plus 15x. 4 terms we group. GCF to the first term, 2 terms is x. Bring down the operator, and GCF to the last 2 terms is 5. 3x minus 2 is one factor, x plus 5 is the other. Equals 0. Set each factor equal to 0 and solve individually. Adding 2, dividing by 3. Subtracting 5. So we have 2/3 and negative 5. As x-intercepts, also known as zeros. And our last one, 0 equals 5x squared minus 10x. GCF of 5x. Set each factor equal to 0. Dividing by 5, adding 2. Thank you very much for your attention.